Hi, welcome to Unit 10, Day 8, our final lesson before we review for our test. We're going to be exploring similar solids or similar three-dimensional figures. We've already talked about how the ratio of our parts is going to be equal to the scale factor. Equal to the scale factor. And we know that the ratio of the areas is equal to the square of the scale factors. And we did that when we previously looked at similar shapes. We didn't look at three-dimensional shapes, we looked at flat ones. So they only had parts like sides and altitudes and radiuses and diameters. But now we're going to be looking at three-dimensional shapes. When we looked at our two-dimensional shapes, we created a SPA table. And we said that the ratio of the parts was equal to the scale factor. So if I had A over B, the ratio of my parts was equal, right? So it was also A over B. So that's any parts. That could be sides or altitudes or radii, diameters, any sort of part. And then, or even perimeter. And then the ratio of my areas, we said we had to square the ratio. So it was A squared over B squared. Well, today we're going to add on volumes, okay? And so for volume, when I add volume to the table, now we're going to become no longer a SPA table. Now we're a SPAV table. You can probably use some deductive reasoning to go, okay, or inductive reasoning, A over A over B, A squared over B squared. And we know when we do area, we always do units squared. And when we do volume, we always do units cubed. So my ratio of my volumes is going to be A cubed over B cubed. So the ratio of the volumes is the cube of the scale factor. So now every time I make a SPA table, I'm now going to include the V column for volume anytime I'm working with three-dimensional shapes. Okay, so let's look at my first example here. The shown solid is similar to a new solid with the given scale factor of shown to new. This part right here is important. When they tell me it is shown to new, that tells me when I look at my numbers, this 3 is my shown information and the 1 is my new information. Okay, so all of this information that's been shown to me matches with the 3, and what I'm going to be finding matches with the 1. Okay, the first thing I want to do is I want to make my SPAV table. S-P-A-V. And they have told me that the ratio, my scale factor, my first column, is 3 to 1. So I know that means my second column is also 3 to 1, which means my third column is going to be squared, right? For area, it's going to be squared. So it's going to be 3 squared, 9, 1 squared, 1 times 1, 1. So my ratio of my areas will be 9 to 1. And then the ratio of my volumes is going to be cubed. So it's going to be 3 to the third power. 3, remember we hit this little up arrow underneath the clear, to the third power is 27, 3 times 3 times 3. And then 1 to the third power, 1 times 1 times 1. It doesn't matter how many times you multiply 1 to itself. 1 to the third power is still 1. Okay, so now when I look over here, I go, okay, I'm trying to find the surface area of the new solid, the surface area and the volume of the new solid. Okay, I know I've got shown over new. So each time I look at these, I've done my 3 is shown, my new is 1. So we're doing shown over new for each one of these. And I'm trying to find the new values. Okay, so when I'm looking for surface area, I'm going to be using my area formulas. I know they're going to reduce to 9 over 1. Okay, where 9 comes from my shown figure and the 1 is my new figure. My shown figure here has a surface area of 1,500 meters squared. So my shown goes on top, 1,500, And I want to figure out, well, what is the new one? So to do this, all I need to do now is cross multiply. 9 times x and 1500 times 1. 9 times x is 9x, and 1500 times 1 is 1500. Divide both sides by 9. And I'm going to get an x value of, I'm going to need my calculator, 1500 divided by 9 is a fraction, and that's okay. It doesn't tell me, or it's a decimal, and that's okay. I'm looking for the surface area. I can round it to 3 places. So after my third decimal, I have a 6. After that is another 6, so I do want to round it up. So this is going to be 166.667. And my units here are meters squared because it's surface area. When I go to look at volume, I'm going to look at my third column. And my volumes will reduce to 27 over 1. Remember, we do the shown value over the new value. My shown value for volume is 3,434.6. And I'm trying to find what is my new value. I am going to cross multiply. X times 27 is 27x equals 1 times 3,434.6. When you multiply by 1, it doesn't change it, so it's still 3,434.6. To get rid of that 27, I want to divide on both sides by 27. And I'm going to get x equals, let's see, 3,434.6 divided by 27, rounded to 3 places, 127.207. After the 7 is a 4, so it's not going to round up. 127.207. It doesn't round up. I could have just written it here, I suppose. 207. And my units are meters cubed because it's volume. Okay. All right, let's look at one more just like that. Okay, so for number 2, I'm going to start off doing the exact same thing. I'm going to start with my SPAV table. S-P-A-V. This time my shown to new is 5 to 2. So don't forget that my shown is the 5 and my new is the 2. And I'm going to do shown over new. So 5 over 2. That's the ratio of my scale factor or my sides. The ratio of my parts or my perimeters is the same. The ratio of my areas is going to be squared, so 5 times 5, and 2 times 2. And the ratio of my volumes is going to be cubed. So 5 to the third power, 5 to the third power is 125. And 2 to the third power, we always come back to our scale factor, 5 to the third power, 2 to the third power. It's real common if you're trying to do this in your head to go, oh, 2 times 3 is 6, but it's not, it's 8, right? Because it's 2 times 2 times 2. So 2 times 2 is 4, times another 2 is 8. All right, so if I'm starting with surface area, my surface areas are going to simplify to 25 over 4. That's my shown to new. My shown surface area is 2,356.2 over my new I'm trying to find. So I'm going to cross multiply 25 times x and 4 times 2,000, 4 times 2,356.2 gives me 9,424.8. We're going to divide both sides by 25. So that I can find the value of my new figure. So x is going to equal, my surface area is going to equal 9,424.8 divided by, I'm just going to hit divided by because I already have that answer in the calculator, 25. So I don't have to retype the whole thing. And I get 376.992, and these are centimeters squared. Now we can do volume. All right, so when I look at volume, I'm going to do the same thing. I'm going to look at these two together. 125 over 8 equals, remember it's shown to new. My shown volume is 7,450.9 to the new volume that I'm trying to find. I'm going to cross multiply. X times 125 equals 8 times 7,450.9. 8 times 7,450.9 is a big number, 59,607.2. I'm trying to solve for x, so I'm going to divide both sides by 125. And x is going to equal, I've already got my 59,607.2 in the calculator, so I'm just going to hit divide that answer by 125. And I'm going to round to 3 places. 8, 5, 7. After the 7 is a 6, so I am going to round that up to an 8. So my answer is going to be 476.858. And my units are cubic centimeters. Okay, that's number 2. In the next video, we're going to look at not being given the scale factor, but we're going to look at given 2 surface areas or 2 volumes or 2 sides, can we find what was the original scale factor? Okay, so come on back so we can see how to work backwards in our table if we're given the values from one of these other sections of our table. All right, so I'll see you in the next video.